Hello everyone. Uh, Today I'll try to solve as many coding problems as possible that actually appeared in the recent years under the exam for TCS-NQT. So at the end of this session, I will try to enlist a couple of programs which would be beneficial for you people to go through and practice. So let's start without wasting our time. So the first one that we're going to go through is finding a factorial of a number. So generally the formula that we use for finding a factorial is simply we go for n multiplied by n minus 1 multiplied by n minus 2 and so on till we reach the end, that is 1. And also it is very important here to note that the factorial of 0 is 1. So whenever we are trying to lay down the same facts in terms of a program, we need to make sure that wherever we have a 0, if the user input or the standard input is a 0, then we have to simply return a 1 in the form of a factorial. So let's have a quick look at how we can program that. So basically a factorial is nothing but, generally when we talk about a non-negative integer n, for instance, say, then the factorial denoted by n factorial is generally given by the product of all positive integers less than or equal to n. So let me so on the right side, whatever you are able to see currently is nothing but a compiler uh, which is offered by Google. Generally we refer this as Google Colab. So Google Colab offers you the ability to store your notebooks, especially when you are dealing with Python language. So we can't call it a compiler. It's a Python interpreter, um, which is offered by Google. And the beauty of this one is that you need not to install any software or packages or other IDEs on your laptop. You can straight away go to your Google Drive and open this and start using this one. And that's what we are going to do today. So the first one to begin with is the factorial function that we'll be going through. So let's first of all define a number, a function that will return us the value of a factorial. So simply I'm trying to check the connection whether the entered number is 0. If it is 0, then probably we are going to return 1, and if it is not, then we are going to return the same number multiplied by the same function again. And this method of calling the same function recursively again and again until we reach our destiny is referred as recursion. So that's all. This is a small function. Now let's try to accept a number from the standard input. So during NQT exam, I guess this is not recommended. Like the highlighted part here, whenever this line number 6 is executed, what happens is the keyword called enter the number, or the string enter the number, is going to be displayed across the prompt. So this is not expected by the TCS-NQT compiler. The only thing is you have to take care that whatever input that is mentioned in the question um, will be directly captured through the standard input, and then it will be used further in your program. So just for the sake of understanding, I'm adding a couple of prompt statements so that the output would be much simpler to understand. So now I'm going to just make sure that there are no numbers below 0, means non-negative. So if a given value is less than 0, then let's print that the input is invalid. Next we have the else block, where I need to print, okay, I think I missed this bracket. So here I'm going to simply return the value that I'll be getting directly straight away from this fact10. So let's put the same value here, and let us see what output we get. Okay, so an improper indentation. Okay, so let me enter the value called 5. The value is 120. This is absolutely correct. So that's a simple program based on factorial. So let's directly move on to the next problem. Next we have, let's calculate area of a circle. So when we are talking about area of a circle, it could be any geometric shape in your exam. So you should be aware of all the formulae. So currently, when we are trying to calculate the area of a circle, we are already aware that the formula is given by pi r square, where r stands for the radius. So one important thing you need to remember here is, if for instance the diameter of a circle is mentioned and you are supposed to calculate the area, then most of the times maybe in hurry, there are chances that students usually um, consider a diameter as a radius. So these are some silly mistakes that may happen. So you need to focus on exactly what quantity is mentioned and what are you supposed to do with that. So it could be anything, like sometimes a square might be given and inside which is a triangle or any other geometric shape. Maybe it would be a concentric geometric shape that is mentioned, and you are supposed to calculate um, the area of the geometric shape that is inside another geometric shape. So under these conditions, you need to properly analyze the heights, length, breadth, and all the things depending upon the formula. So do take care of all these things. And now, just for the sake of this calculation of the circle, let us import a function called math. So I will be importing pi from the math library from our Python. So let's see how we can do that. So this is going to be area of a circle. Here r is going to be the radius. So let us first of all import pi. So we have imported the value of pi from the math library. Now let us just verify what value we'll be getting if I print it. So this is a long floating number. This is a pretty high resolution float number. So depending upon what quantity you have taken, some people actually tend to consider this as a constant of 3.14. But if you consider this entirely, then definitely it is going to make certain difference in the answers that you calculate in comparison with a constant just having a resolution of 0.2 decimals. So let's go ahead and define a small function. Let us call this area of circle, and it is going to accept radius as a parameter, and this is going to simply return pi multiplied by the radius to the power 2. Now let's accept the value of radius from the standard input. So let's simply put a message prompting for the radius as enter the radius, and then we are going to directly print the area of the circle. So let's call it okay, I'll directly write AOC is. So let us properly terminate this by mentioning the end. Now let us directly call this function here. So let the radius be 5. Okay, we are having a couple of errors. Let us find what it is. Unsupported operand type S for double star str. Okay, so spaces are not allowed. So that doesn't create any difference. Unsupported type. Okay, so the first thing is that it is not allowed to have a string and an integer. Yes. So since pi is being considered as a string here, what we can do is let us convert the input into float here itself. So this should resolve the error. Let us check. Okay, so now the answer is really lengthy. For instance, let us say that you are supposed to um, display the answer with just 2 decimals. So let us add one more print statement. Print. Okay, so let me copy the same value. Now let us try to round this off to 2 decimal places. Let us check what's missing. more parenthesis is missing. Okay, so this is how you can take care of the decimal points as well, by getting the answer at the desired decimal resolution. So let's move on to the next problem. So let's write a program to identify whether a given year is leap year or not. So for this, we need to understand that a year is a leap year, which contains an additional day, probably this date, that is February 29th, is going to be extra in a given year, and that's the reason why it becomes a leap year. And along with this, you need to take care that the given year is whether divisible by 4 or not. And generally we have a concept of identifying whether a given year is a leap year or not by following certain rules. So let us have a look at what are these rules. So to determine if a year is a leap year, uh, let's lay down these three rules. So if if a year is evenly divisible by 4, it means we should not have any remainder left. Then we are going to go to the next step. So the first thing we are going to check is whether it is divisible by 4, and if it is not divisible, then it is not a leap year. If it is divisible, then we are going to move to the second step, that is whether if it is divisible by 4 but not divisible by 100, then it is not a leap year. Similarly, we have another condition, that is it is divisible by 100 uh, but not divisible by 400, then it is not a leap year. So the condition here is this. So let's have a small example. For example, if a given year, like maybe 1997, if it is not divisible by 4, okay, so this is going to leave some sort of reminders. So since it is having some remainder left, it is not a leap year. So we are going to move further. If it is divisible by 4, like for instance, let us say 2012, this is definitely divisible by 4, yes, but it is not divisible by 100. It is not divisible by 100. So it is still a leap year. We are going to move to the next step, that is if a year is divisible by 100, it is divisible by 100 but not divisible by 400. For instance, let us take example of 1900, then it is not a leap year. So these are the three things you should be taking care of while you are trying to convert this particular puzzle of identifying whether a given input year is a leap year or not. So let's have another example of year 2000. It is divisible by both, that is 100 and 400, and hence it is a leap year. So we need to keep an eye on the remainders that are left after dividing it by 400 and 400, and just follow the same approach while converting that into a Python program. So let's have a look at how we can do that. So let's first of all define an input for the user to enter an year. And let's convert that into an integer here itself. Okay, so next we have the condition for checking it whether it is divisible by 4. And we are interested in the remainder. So let's put this percent sign. This is the condition within which we are going to check for another condition, that is if the year is divisible by 100, and if it is divisible, then we are going to move further and check for one more condition, that is if the year is divisible by 400, then we're going to straight away let us print it so that it will be easy for us to look at the output, and if there are any errors we can debug it out. Okay, so let's print the message as is a leap year. If it is not divisible by 400, then of course that particular number is not a leap year. So this is not a leap year if it is not divisible by 400. Similarly, getting out of this loop, if it is not divisible by if it is divisible by 4 as well as divisible by 100, then also we may print that it is a leap year, like the example we have seen here, 2012. So let's have it now coming out of the loop. If it is not divisible by 4 itself, then also it is not a leap year. So this is a simple program. Let us compile and check whether we have any errors. Missing quotes. Okay, the same error we have everywhere. So let us take the same example, like for example 1997. I'm going to take this and let us check whether we are having the same answers as an output or not. So 1997, it is not a leap year. Yes, that's true. Let us execute again and check for 2012. 2012 is a leap year. Yes, though it is not divisible by 100, leaving no reminder. So now let's check for the year 1900. Yes, this is also not a leap year. Now let's check for 2000. Yes, 2000 is a leap year. So that's how we can write a simple program for checking whether a given year is a leap year or not. Let's move on to the next example. Another simple program that usually appeared in NQT was GCD or HCF, that which is referred as highest common factor. Was asked in a couple of exams. So let's have a look at what is a GCD first of all. Basically, GCD is nothing but we can identify that for a given number, for instance, let us take two numbers like 12 and 14. The highest common factor which is going to divide both the things is going to be 2, not more than that. So the reason for this is very simple. Like for instance, we are going to simply identify the factors. Like we may go for even another example where we take the numbers as 54 and 24. Here the HCF is going to be 6. So basically what we do is we simply take two numbers and then identify all the factors which easily divide the given number n, and then we identify the common factors out of that, and then we simply tend to calculate these highest common factors. So the same approach we are going to follow. You can even go for functions or loops. So let us directly write a simple program to do this. We need to take care of a couple of things while doing this. That is, what if a user enters the number as 0? Okay, so that may raise some sort of exceptions. You need to take care of these things by implementing error handling in your Python program. So let us simply write a program to prompt the user enter two numbers. Let's take two variables, a so these are the two values. Next, we need to also take care that the number, the factor that we are going to identify will not be less than 1. So that's the reason why we are taking I as 1. Next, we'll be checking whether whether the given number is less than or equals to 1, because we can't go for factors below the given value. So I is nothing but 1 in our case. So whether it is equal or less than a, and we need to also check whether the given number is less than or equals to the other number b. Okay, so once this is checked, and if it is true, then we are going to find two things. The first one is whether the given number is leaving any reminder. If yes, then we can proceed for incrementing and further dividing it. So let us, for instance, assume that a and b are 1. The user has entered 1 1. So it is the resultant is going to be true. So after entering inside this if loop, we need to simply print that the GCD value is 1, or simply I. So that's one part. And if it is not, Then we need to come out and increment the value. And then this is going to be looped again and again until we get the final answer. So finally we get the answer here, that is GCD So let's verify. Let us add the same values 12 and 14 to verify. So 12 and 14, yes, the GCD is 2. Let us verify for another set of variables, that is 24. Okay, so by mistake I typed it as 25. Let us go for 55. Okay, the GCD is 50. GCD is 5. Let us go for 54 and 24. Yes, the GCD is 6. So similar to this one, let's proceed on to the next problem. So this is one of the most favorite question, that is identifying whether a given number is a prime number or not. So let's check what is a prime number. Prime number is nothing but the general idea that we usually have is the number should be divisible by 1 or itself. Okay, then and only then we say that that particular number is a prime number, and it should not have any other divisors. This is also an important condition. So further, what we have is the idea to generally solve this problem is to iterate through all the numbers starting from 2. We are going to leave 1 because it is neither prime nor a composite. So we are going to start dividing the given number n from 2 till n by 2. So for instance, if the entire number is 10, then we are going to divide it by 2, 3, 4 and 5, and we are going to stop it at 5 because in our case 5 is going to be n by 2. Maybe by using a for loop or any other method. And for every number, we are going to simply check whether it is going to divide the given number n or not. And if you find any number that divides, then we simply return false. So based on the value that we are returning, whether false or true, then we are going to simply say that the given number is prime or not. So let's directly move on and write a program for this. So first thing is, let us define a number. Let's take a number from the user and let's ask him to enter a number. Next, what we have, we're going to check the condition whether the given number is greater than 1 or not. If it is greater than 1, then and only then we're going to proceed ahead. Otherwise, we're going to simply end up the program there itself. So the next part is to loop it through a range that begins from 2 till the entered number. So in this, we're going to check if the given number leaves any remainder. If it doesn't leave, means it is a not a prime number. So straight away we're going to print that it's not a prime number, and we are going to this is very important, so we need to break the loop here itself, so that we are going to directly come out of the if loop, and else it is a prime number. Next, and if it is not greater than 1, then let's raise a warning or directly state that is not a prime number. Let's execute and check whether, for instance, let us take 1. Okay, it's not supported, so the error is that comparison between this string and integer is not allowed. Okay, so we need to first of all convert the given input into integer by typecasting this, and let us check whether it will resolve the error. Yes, so let us verify it once again. This time let us go for 17. Yes, it is a prime number, and yes, there was a mistake. There is a little bit of tweaking in here, so, but this is how you are supposed to solve the given problem. You can easily resolve this by breaking the statement, and if you're not breaking it, this is what is going to happen. You're not going to come out of the loop. So currently, even though the condition has become true, even then the else condition is being iterated because of the remaining iterations of the for loop. So we can do one thing. Let us check if this works. Yes. So these are some silly things that may save your day. So next, we can raise the complexity of the same problem by finding prime numbers in a given range. So the same logic applies here as well. So we'll use the same logic that we have implemented here, that is trying to iterate a given number by dividing it step by step, and then identifying whether it is a prime number or not, and then we are going to identify all the prime numbers in a given range. So whenever we say that we want to identify a range, we need to talk about a lower limit and an upper limit. So for the sake of doing that, let us first of all define a couple of variables. So let's go for a, b, I, j, maybe anything else. Okay, let's take one more flags are generally used for keeping an eye on the status, like whether some things are true or false. So let us initialize all these values with, and one more 0. Okay, so let us prompt the user. This is not supposed to be done in your exam, but just for the sake of having a better output now, I am writing this. So let's end this properly. Now let's accept the input from the user. Okay, and since these are going to be accepted from the user, and we are again about to define prime numbers, so we'll do the same thing of typecasting the given numbers here itself. Okay, and let's do the same thing even with B. Enter, let's call it A for lower and B for upper bound. Okay, so these are going to be the lower and upper limits. Let us make sure that whatever numbers they are entering are the same by printing them. I assume that there will be some errors. Okay. Fine. So we have prompted the user to enter two numbers, and then we are going to print it. So let's first of all verify. Let the lower limit be 10, upper limit be 50. Okay, so it's working correctly. Now let's go ahead and edit it further. Now let's print prime numbers in the range are okay. So now the real algorithm comes into picture, that is for I in range from A to B. Again, I hope you people are already aware that it is going to work till B minus 1. So better we add 1 here. So this A comma B plus 1 is going to take care that we are going to iterate from A till B. Next, in this we are going to check if the iterator I is equals to 1. If it is already 1, we need not to calculate exactly the way what we have done previously here. So we're going to simply continue, means do nothing, and just pass on to the next part. So here we're going to make the flag 1. So flags can be used as gates, like when to open and when to close, depending upon it generally adds a sort of control to your code. So next we have for let me go with J. In the range, as we already done it previously, we're going to start iterating it with 2, and then we're going to use a floor division operator, that is I double slash 2 plus 1. So the floor division actually rounds off the result. So for instance, if you're having some decimal values, it is going to simply round it off. This is going to be appended with a function with a condition of I. If I divide it by j and checking for whether I have any reminders. If it is equivalent to if it is equals to 0, then let me make the flag 0 and break the statement. So why do we need to do this? Now the flag is going to come into picture, that is, if flag was 1, I can directly jump to this condition. So here I'm going to check if flag is equals to 1, then directly print the value of I. So let's check what do we have here. Let the value be 1 and let the upper limit be 5. So prime numbers in the range are 235. Okay, so where do we have it? So generally we have this 2 and 3 and 5. Can we check this with a space in between? Okay, so the prime numbers between the range 1 and 10 are 2, 3, 5 and 7. Yes, that is absolutely correct. So let's go for a higher range and check whether it correctly displays the things or not. So let's try to put the lower limit as 50 and upper limit as 100. Okay, so we are having approximately 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. Yes, it is absolutely correct. So this is how you can even print the values. So while you are doing this on a TCS-NQT platform, probably you are not supposed or you are not allowed to print all these things like enter lower limit and upper limit. Directly just assume that you will be getting two inputs, the lower limit on the first line, the upper limit on the second line. You are only supposed to print this much, 53, 59, 61 and rest all the things till 100. We can even move ahead and proceed with our next problem. So there are a couple of other problems, like once you are aware of what is a prime number and the kind of problems that you have seen here, like a range, you can even check whether a given year is a leap year or not, whether a given number is a prime number or not, whether a given string or number is a palindrome or not, whether a given number is an Armstrong number or not, whether a given number is a perfect number or not, whether a given number is a friendly pair or not, whether a given number is an automorphic number, whether it is a Harshad number, whether it is an abundant number. So there are a couple of more possibilities that may come in your NQT exam. So I want you all people to go through that. I'm going to post the link of this entire document below the video description. You can go through that notebook and identify the examples like these and practice. So let's move ahead and try to solve one more quick problem. So similar to that one, let me write a program to identify whether a given number is a strong number or not. So what do you mean by a strong number? Basically, when we talk about the types of numbers, there are many. So the way how we have various types of matrices like a skew matrix, singular matrix, upper triangular matrix, lower triangular matrix, similar to that one, whenever we talk about numbers and the types, especially while we are dealing with programs like NQT, then a strong number is a number whose sum of factorials of the individual digits is equal to the number itself. Like for instance, say the number 145 can be split into 1, 4 and 5. So if you take the sum of the factorials of these individual digits, it will be equals to 145, which is equal to the given number itself. So this makes the number 145 a strong number. So that's how we identify. Similar to these things, we have lots of other examples like Armstrong, abundant, Harshad number, automorphic number, and friendly pairs. There are lots of puzzles available online. You can go through it. Now let us write a small program to identify this part. So for this, let us define a small number first. Let us typecast that into an integer variable. I'm making sure that the formatting is correct. Okay, so now I'll take a variable and will initiate it with 0. Let us even go for a temporary variable to hold the value of the number. Now when we say that we have factorials involved in this, okay, so just now we have gone through the factorial programs somewhere here. I think it was first. Okay, so here as you can see, if a given number is 0, then we have to return 0. This condition is mandatory part of a program whenever we are dealing with factorials. So the same thing even applies here. We need to first of all check whether the given number is greater than 0 or not, and if it is 0, then we can straight away return one value and leave it. So for doing the same thing, we need to take care that the 0 factorial is returned with a 1. So let us check that only while the value is greater than 0, we return 1, or simply we make the factorial 1. So once that is done, let us take another variable to store the remainder. So let's iterate. Now let's iterate I in the range of 1 till remainder plus half. So this is just like again iterating it through the given sample space. Now factorial is factorial into, so this will be okay, so this will be I. So what I'm simply doing is multiplying the iterator with the previous factorial value that I'm currently storing. So the fact value initially starts with 1 and then it gets multiplied with 2, 3, 4 and so on till n. So I'm simply trying to identify the factorial of these individual digits. So first of all, I have split up the value into digits, and then we are simply trying to calculate the factorial. So just for the sake of simplicity in understanding, let us print the factorial of individual numbers and check whether that prints or not. So for printing that, factorial of let's go for format specifier this time, something like C language. So what I want to display here is, first let us go for the digit, because remainder this is going to hold the individual digits like 1, 4 and 5. So after printing remainder, I also want to print the factorial of that particular number. So let us first of all check whether this is working or not by partially executing this. So if I enter the number as 145, okay, so somewhere it will also display 4. So currently it's a partial program, so definitely we're going to stuck up somewhere here. Okay, so let us verify this. Fine. So if I break it here, the rest of the iterations are lost, but the factorial of 5 is 120. So I need to continue this to print the factorial of 4 as well as factorial of 1. So let us do that. Now we need to find the sum and add it to the fact. Similarly, we need to take care that temp is floored by 10. Now let's print the values. again by using the format specifiers. We need to display the values of num and the sum. So here we need to also check, we have another condition, that is if um, sum is equal to number, then and only then the number is a strong number. So this is the main part here, which declares whether the given number is a strong number or not. So I'm going to simply print the number is a strong number, else simply print the number is not a strong number. So let's verify if we have any errors. So let it connect again. So if we're using Google Colab, we need not to worry about the resources that it offers, but simply uh, wait for Google to allocate the resources. And okay, so now we can compile this. So it is asking us to enter a number. Let us enter the same number called 145 and check whether it is going to give us the factorial. Okay, so that's perfect. We have factorial of 5 as 120. Then we have replaced it. We have actually stored it inside the sum variable 120 plus 24. So again we have factorial of 24. Now this is 144. Next we have factorial of 1 as 1. Now this has become 145. Hence sum becomes equals to the number which was entered by the user, and hence the given sum uh, is equal. Therefore the given number is a strong number. So we have printed the entire log, like just for the sake of debugging this in case if we have any errors. But okay, it's some, let us enter some other number like 123. Okay, this is not a strong number because the factorial of 1, 2 and 3 is 9. You may have a different logic while uh, having a similar kind of problems during your examination. That is, you may need to just print yes if it is a strong number and no if it is not a strong number. So make sure that you are not printing any additional spaces and rest of the junk, otherwise that will be treated as a fail case. So moving ahead, let's go for one more problem. Okay, so let's make these things a little bit more complex. This time let us identify, let us try to solve one of the problem that appeared in one of the quiz on HackerRank as well as some other platforms. So the simple quest here is to find the smallest number, but not just the smallest number, but also the second smallest number. So when we are talking about these kind of puzzles, like finding the mid value, maybe the median value, maybe the mean, mode and variance kind of concepts that actually come out from statistical analysis. So not only that, but also second smallest, third smallest, second largest. So these kind of logics you can easily implement. So let's try to identify uh, the logic behind identification of a smallest and the second smallest number so that it covers both the things. So let's write a small program for finding the smallest and smallest number in the array. Of course, it needs to be an array. So we have a small logic. Let me clear this. So the logic behind this is based on a small algorithm. So the algorithm is basically that we need to first of all initialize or find the first and the second smallest by using int max function. So there is a function called int max in Python 2.7. I think that's replaced by a function called int underscore max size in Python 3. So we're going to take help of these functions from Python, and then step number 2 in the algorithm is going to simply to loop through all the elements of a given array. So in this we're going to follow two-step approach. So the first step is going uh, to check if the current element is smaller than the first one. If so, then we're going to simply update the first and second one, a sort of a bubble sort. Okay, so this is a kind of a bubble sort. You need not to be aware of these concepts, but anyways, since you people are in third in BI, I presume that you people are already aware of these data structures. And the second step is going to be to assess whether the current element is smaller than the second, and then update the second. So updating the first and then updating the second, and hence we're going to loop through all the elements uh, to do a kind of a bubble sort. So let's do this. Okay, so let's define an array and take the input in the form of integer by typecasting the given input and prompting it with a statement to enter the number of elements. So this will be helpful for us to um, identify the depth of our for iterator. So we'll be using the same information of n to iterate in the range of 0 to n. So since we're starting with 0, we can directly end it with n. Now let's take a variable ele to store the input data. And then we'll try to append these things to the array that we have just defined. So arr dot append will append those elements. Okay, so let's define a function now. Let us call this print small. So this will print, okay, so let's call this print smallest. So this will print the smallest variables. Okay, to make it more explanatory, let us call it print to smallest. So it will be printing the smallest as well as the smallest second uh, values of the given elements in the given array. So it will be accepting the entire array as a parameter, and let's define the size. So the size can be easily extracted by the length function. So let's check if the array size is less than 2. So this is a sort of error handling. If you don't check for divide by 0 for uh, any equation that divides something in a given program, then that is going to create an exception. Similarly, multiplying something with an infinity or dividing something with a 0, anything which is going to create a sort of math error should be handled first of all. So similarly here, whenever we are dealing with arrays, we need to take care of the exception that goes beyond the limit and which raises the exception called out of bound exception. So we are taking care of the same exception here by writing by assessing the array size. If it is less than 2, then we're going to straight away handle it or put a warning stating that it is invalid input, and then simply return nothing. So once this is done, let us take few more variables and initialize them with a max size. So max size is a function that is available in Python 3. It was earlier called maxint in Python 2.7. So while importing these things from sys, it is very important to import the system this is library, otherwise that will be raising an error at the end. So now we currently are holding first and second variables with a max size, so that will be enough. Okay, so now we are going to have one more for loop to scroll through this entire array ranging from 0 to array size. And here we'll be simply implementing the logic of a bubble sort. That is, first element will be compared with the first element, and second one with the first, and first one with the second. So simply we are simply we are trying to update the first and the second values. So if ARR of I is less than the first, so if it is less, then simply we are going to swap the values. Second will become first, and first will become The second means the same value that is stored in ARR whose value is less than the first value. So now after updating this, after line number 17, the first value will be less 1 and the second value will be a bit higher value. Now we'll go for a recursive else if, where we will be checking whether this ARR of I is less than the second one. And also we will check whether this ARR of I is not equals to first. This is important because we don't want the elements uh, to be swapped if the values are equal. So if that is the case, then we are going to store that in the variable called second. So similarly, we are going to check with the second variable, that is if second is equal to sys dot max size, then we can say that currently this is going to be the second smallest one. So let us directly print the value of so the reason why it is not a second smallest value is that the condition second becomes equals to sys dot max. So let me explain you this in detail, but let's first finish this. Else, if the condition is not true, that is if second is not equal to sys dot max size, then we'll end up with two smallest values. So let us call this the smallest element is first, and the second smallest value is going to be second. So let us call this function, that is print to smallest, and pass the array. So let's check there are any errors. Okay, so somewhere we have an error in line number 23. which states that the smallest element is first. Okay, line number 23 says that input in has having an invalid syntax. Okay, so did we miss anything? Okay, so we got to have this comma after this. Hopefully this should resolve the errors. Okay, so we are supposed to, okay, so just forget about these spelling mistakes. We are supposed to enter the elements. So what is it prompting for? So let us enter 5 elements. So this is the 5th element. Okay, so the smallest element is 1 and the second smallest element is 8. Fine, we are getting the right answer. Now let me tell you what exactly we did. Okay, now just have a look at what we have done. Let us take the same example of 189, 16 and 20. So we have an array that was input by the user of the standard input, where we had the elements 1, 8, 9, 16 and 20. So here as we are checking, that is if the first element, that is ARR of I, that is ARR of I, if this particular variable, if this particular element is less than first, then we are going to simply replace the second with the first value. So why are we doing this? So before doing this, we need to make sure that we have two variables, that is first and second. Second is going to be the second smallest and first is going to be the smallest variable or the smallest element in the given array. So we need to always make sure that first is less than second. Okay, not second, but second is always less. Okay, second must be bigger. Okay, that's fine. We are correct. So we need to always take care that first is the smallest value and the second smallest is going to be the uh, bigger value. So rather than getting confused, let us call this first smallest and this is the second smallest. Of course, second smallest is going to be less than the bigger than the first smallest. So initially we need to make sure that these two values are at their maximum value, because of which we are importing the function called we are taking the benefit of the function called sys dot max size. So who defines this? The max size is going to be something like this max size function is going to dictate the max size of whichever architecture you are on. So let us just check if it gives us. So currently this particular collab is working on Google servers. You can see that it has offered a certain RAM and disks. So the Google servers, no matter on whichever architecture they are working on which this Google Colab server is hosted, this is the maximum size that we could possibly hold inside a variable or whatever Python um, can depict. So initially we are making sure that fs, the variable first and the second are stored with this value. Why we are supposed to do this? Because there are possibilities that this could be one of the value um, among these 5 elements whenever we are entering the values. So let us check if this works. I'm going to copy this and re-execute this particular value. And if I put this value, uh, okay, so first we need to enter the number of elements. Fine. So I'm going to enter 3 elements, out of which one is going to be 5807. Second one is going to be 5808, which is which should not be allowed technically. And this will be 5809. So let us see what answer we'll be getting. No second smallest value. So the problem is here these values are being overwritten. Like this is going to be the max value that can be held by the variables in Python, because this is the maximum value. So we are simply taking care that this there would be no value more than this. If we don't take care of this value by equating the first and the second variable with sys.max, then probably this condition is going to become false. I mean, whatever value that we are iterating and comparing it with the individual elements to find the first and the second smallest variables are going to be false whenever we are comparing these two conditions. So on the other hand, alternatively, if we are trying to calculate the largest and the second largest variables, then probably the first and the second variables should be equated with 0. So since we are trying to identify the smallest and the second smallest variable, we need to make sure that initially these must be initialized with the maximum value possible. So how can we identify the maximum value possible? We can only identify it by identifying the architecture. And since by importing this particular import sys, the system's function called max size is going to offer us or return us with a value which the available architecture is going to allow. And this is what has happened now. So let us execute this again and put the values back into picture. That is, this time let me go for 23, 9, 6, 48 and 99. Okay, I should have actually entered 5 first. Okay, let me re-execute this. I want to enter 5 elements. First one 23, 19, 8, 48. So what is the problem? I'm entering it too fast, I guess. So let us check this. 12 first, then 99. Let us go for 43, 9, and maybe 5. 5 should be the smallest and 9 should be the second smallest. Okay, so let's go with the same values. Let it be 12, 99, 43, 9 and 5. So the max value, that is this particular value 92222 whatever, so let us call this x. Okay, so this is the max value. So max value is compared with 12, uh, that is ARR of I is going to be 12. Is it less than the max value? Yes. So I'm going to simply put that inside the second variable. So the max value gets into second and first value gets occupied with the value 12. So currently, okay, let's make a small table. This is max now and this is 12. After that, we are going to compare whether this ARR of I is less than second and ARR of I is not equals to first. Okay, that is going to be false. So if that is going to be false, the meaning is that both these values, first and small, I mean the first and the second variables are both going to be equal. When this condition is going to happen, this condition is going to happen whenever we are entering just three elements, and if all the values are 1, 1 and 1, then this condition is going to be true, like ARR of I is not equals to first, and also second is not going to be ARR of I, because both are going to be equal at one or the other iteration of comparison. So just to avoid this condition, we have to take care of this else if recursive if else block. And on the other hand, if this condition, that is second, is equals to max size, then this is as good as this remains with the max size, means we didn't find any smallest second variable. So this could be the case when we are entering the same variable again and again, or we have entered a number which is more than the max size that is allowed by the architecture. So these are the two possibilities, only two possibilities. So if you are facing any unattended test cases during your online exam, you need to take care of these things. You may put a max size condition and try to handle it through error handling. But I suppose such kind of a little bit tough problems won't be the part of your TCS-NQT, because you hardly have 20 minutes to solve this. So that is one part. Similarly, we are going to iterate all these things. We are going to compare it with ARR of I is going to be compared with first. Again, it is going to be compared with 43, then 9, then 5. So in the second iteration, while we are comparing it with first, the condition is going to be false. Like ARR of I, that is 99, is going to be compared with FS, which is going to be 12. It is not true. So FS is already smaller than ARR of I. So this condition actually becomes false. Similarly, this if condition, ARR of I is less than first, is going to be again be treated as true when we are comparing it with 9. So 9 if compared with 12 is going to be true. Then again we will be having a chance to copy the value of first, that is 12, copied into second, and then the value 9 is copied into the first. So again we are going to compare 9 with 5. We found that ARR of I is less than f of s. So what will happen? This 9 will be copied to second, and 5 will be copied to the first. So ultimately what we are having now, this condition, that is ARR of I is less than second, is true, as well as ARR of I is not equals to first is also true, and hence we have that second value fixed in the second variable. That is, now the first variable will be holding the value of 5, and the second variable will now be holding the value of 9. So that's how we identify these two smallest and the second smallest variables. So that's a simple logic. I think this particular explanation is enough for you people to understand. So we can finally stop here, and I suppose that this is going to help you at least by some percentage. And I am posting this entire notebook with a couple of modifications, and by adding some more examples in the video description. As you can see, you can directly download it from the folder available there and use it for your own purpose, and also practice the questions that I have mentioned in the form of example titles. So thank you for attending.